Hello everyone, welcome to Sir Rob's Math Lab. Now today we're going to look at some geometric proofs. Now let's have a look at this question here. Triangle ABC is isosceles with AC equals to BC. Triangle CDE is isosceles with CD equals to CE. ACD and DEF are straight lines. Prove that angle DCE is equal to 3x. Now, let's go ahead and prove that DCE is equal to 2x. Now, before we do that, I want to highlight some of the key information in this question. So for one, isosceles is important. AC is equal to DC. This is also important. CD, CD, CE is also important. Good. Now let's go ahead and look at triangle ABC. So triangle ABC is isosceles. We know that AC is equal to BC. So we're just going to make a mark just to say that these two sides, they are equal. All right, so AC is equal to BC. And for triangle CDE, we know that CD is equal to CE. So we're going to make a mark using a different color. Okay, all right. So now we're looking at two triangles. We're looking at triangle ABC and triangle CDE. Now we want to start with the triangle that has more information. Now if we look at triangle CDE, it doesn't have enough information. All right, so we're going to look at triangle ABC, where we are given more information, which would be this angle right here. So triangle ABC is an isosceles triangle. We know that the base angles of an isosceles triangle, they are equal. Now, if we know this base angle, we can say that this base angle is also x because they are equal. Now here for triangle ABC, we realize that we have two angles. Now once we have two angles in a triangle, we can go ahead and find a third angle by subtracting those two known angles from 180 because the total angle must add up to give you 180 degrees. So the third angle here, it would be angle ACB. So let's go ahead and find angle ACB. So angle ACB is equal to 180 minus the known angle. So here we have the two known angles, which would be 2x. So angle ACB would be 2x. All right, so let's go ahead and just put it in right here. So 180 minus 2x, so that is angle ACB. Okay, so to know that we have angle ACB, we can go ahead and find angle DCE. So angle DCE now, realize that it is on a straight line. So here we know AD is a straight line, and we know that angles on a straight line, it adds up to give us 180. So to find a missing angle on the straight line, we subtract the known angles from 180. So here we go, we want to find angle DCE. So let's go ahead. So angle DCE is equal to 180 minus the known angle. In this case, it's going to be 180 minus 2x. All right, so let's go ahead and expand and simplify. So 180 minus 180 plus 2x. So you're going to be left with just 2x because 180 minus 180, that is 0. So angle DCE is equal to 2x. So therefore, it has been proven. All right, so QED has been proven. Now, let's put in the angle here. So we know that angle DCE is equal to 2x. Now, if we know angle DCE, we can go ahead and find angle CDE as well as angle CED. All right, so you can go ahead and find those angles. Now, let's go ahead and find angle CDE. To find angle CDE, remember that this is an isosceles triangle. So if we subtract the known angle from 180 degrees and half it, we automatically get one of the base angle, which would be either angle CDE or CED. But we're going to focus on angle CDE for now, yeah? So angle CDE is equal to 180 minus the known angle, which would be 2x. And to get it for just CDE, we're going to half it. So we divide by 2, and it's going to give us 90 minus x. All right. So angle CDE is 90 minus x. Let me see if I can put it right here. 90 minus x. Good. Now remember, our aim is to prove that DF is perpendicular to AB. So here you have DF is perpendicular to AB, and we know when two lines are perpendicular, we know that it form a 90-degree angle. Okay, so we're hoping to get 90-degree for this missing angle. So we don't know this missing angle, so we're hoping that it is 90. So this angle here would be AFD. So AFD. So let's go ahead and try and find that angle there. So here we're looking at triangle ADF. So triangle ADF, we are given, well, we basically know two of the angles. So you know this angle here, which is x, and you know this angle here, which is 90 minus x. So if we subtract these two angles from 180, we would get the third angle, which would be this missing angle right here. So let's go. So it is 180 minus 90 minus x minus the third angle, which would be, no, would, yes. So you can minus this angle here, which would be x. So you're going to subtract x. So 180 minus 90 plus x minus x. Good. So 180 minus 90, that's going to give us 90. And x minus x, that's going to give us 0. So therefore, we can say angle AFD is equal to 90. So if this is 90, it means that AB is perpendicular to DF. So therefore, you have proven that DF is perpendicular to AB. All right. So you have proven that. Okay, so I hope this helps. So thank you for watching.